Hi everyone, my name is Thomas Kim. Today is March 4th, 2020. This is my 37th episode about 3D graphics, Intel TVB OpenCL Vulkan using Microsoft Visual C++. In this episode, I will discuss the future of C++ standard. As you may know, I am not a member of C++ standard committee. However, I think I have an eye to see the future of C++ standard. C++ standard is composed of two things, the C++ core language and the C++ standard library. In this episode, I will not discuss the C++ core language, but I will talk about the C++ standard library. When we learn programming for the first time, we usually learn iterative loop prior to recursion or recursive function calls. If you are unfamiliar with recursive function calls, don't worry. Recursion is much simpler, more elegant than iterative loop. Once you get the hang of it, recursion comes to you as a piece of cake. As you may know, the nature is recursive. Once our recursion-based algorithm works correctly, then we can easily convert it to iterative loop-based algorithm. We are, or most of us are, accustomed to sequential algorithms. If you have been watching my videos for some time, you must have noticed that I take the following steps to make parallel algorithms. First, I create correctly working sequential algorithm. Then I sort out parallelizable paths out of the sequential algorithm. Then I convert the sequential algorithm using either C++ standard parallel algorithms or Intel TVB library. Lastly, I do profiling my parallel algorithm by comparing with the sequential version. Implementing parallel algorithm using lower level C++ threads is hard and difficult and error prone. But with C++ 17 standard, the C++ programming language introduced C++ standard parallel algorithms. As you must have noticed, I create parallel programs rather easily by using either C++ standard parallel algorithms or Intel TVB. Once we get familiar with recursive function call, the domains of the problems we can solve are immense. In the same manner, once we get familiar with parallel programming techniques, parallel programming becomes as simple as sequential programming, and we can fully harness the modern computing resources. Traditionally, parallel programming has had a bad reputation for its difficulties. That is true if we are to use low-level multithreading. The C++ standard has been from 1 to 3 or even 4 the case behind the industry. For last 2 or 3 the case, parallel programming techniques have been researched and tested, and task-based parallelism has been tested over 1 or 2 the case now. With the C++17 standard, the C++ programming language introduced standard parallel algorithms, which are based upon task-based parallelism. If we create our programs using task-oriented or based parallelism, not a single thread in our application needs to be blocked or goes idle for synchronization, such that our application fully takes advantage of the hardware and software computing resources. Intel TBB is implemented using task-based parallelism, which is the foundation for C++17 standards parallel algorithm. I will fix this typo synchronization. So my point is that Intel TBB or task-oriented parallelism is the future of C++ standard. It's just a matter of time. Without further ado, let's get started. Start Visual Studio Code. Open your working folder. Select empty space. Click this button. 37. The future. CPP. Hit enter. Click this button. Task.cpp. Hit enter. Ctrl V. In this episode, I will prove that C++ standard parallel algorithms are built upon task-oriented parallelism, as in Intel TBB. Include talk, play, fun, output HPP. Include talk, play, fun, parallel HPP. Include talk, play, fun, chrono random HPP. Include TBB malloc proxy.h. Include TBB mutex. Ctrl-Shift-P, edit configuration JSON. You have to make these environment variable settings. Ctrl-S, Ctrl-W, then the squiggle goes away. Namespace, CHR means chrono random. Talk, play, fun, chrono random. Talk, play, fun, stream, auto, endl, talk, play, fun, endl. Using mutex TBB mutex. We declare a global mutex mutex. Void test std parallel algorithm. Size t, element count. I will set 10 default value. Int main. I will copy this function name. Copy, paste it here. I will remove this part. Now start command prompt. dir cd 37 the future cpp cl ehsc std C++17 task.cpp fem.exe. You should be able to build successfully. Now here we create a block mutex t. Please note that we defined the mutex t here. It is an alias. Scope lock mutex. Stream the main application thread ID TBB. This thread, here include tbb.h. We have to include this header file tbb. This thread get ID, and there, or if we include thread Then we can also say std this thread is the same. I say main thread ID. Now here using element t double using container t std vector element t container t cntr means container element count. We got element count through argument std iota cntr begin cntr end element t1. Now we shuffle this cntr std shuffle cntr begin cntr end std mt 19937. We provide chr seed. This chr seed is defined in talk-play-fun chrono-random here. Now we display stream unsorted cntr and there. Now we build once again clsm. So the main thread ID is 8324. This is 10 numbers. Now std sort std execution parallel cntr begin cntr end. We provide a lambda here. It should take auto. I will just use forwarding reference A auto B. In this block I create a block mutex t scoped lock mutex. I forgot comma here. Stream worker thread id std this thread get id and there. Now return a less than b. I will copy this part, copy paste the thread id in function. I will copy this part, copy paste. Now we run this function. Now here stream after sort cntr and there I will say before sort. In the command prompt again we build again cls m. If we scroll up the thread id in function 3492, these are using the same thread IDs, so single thread is used in this case. Now we increase the element count to 100. We build again clsm. The main thread ID 11412. The thread ID in the function 11412. The same thread ID, the same thread. In this part, it is using main thread ID, main thread. If we scroll down, I scroll down, there is another thread ID. If we scroll down, there are other thread ID. If we scroll down, the thread ID in function 11412. This main thread ID is recycled in this part, also in this part. Please note that in our code, this is parallel block. In parallel block, the thread ID in this function or main thread ID or main thread is used here. If we used low-level thread, our main thread must have been blocked. This example proves that std sort, std execution far is implemented using task task-oriented parallelism internally. And our main thread, or the callers thread, is not blocked and participates in the SDD sort algorithm too. I believe more and more parallel algorithms will be introduced to C++ standard. These parallel algorithms will be implemented using task-oriented parallelism, as in Intel TVB. If you give more like buttons to my videos and I gain more audience, then I can more frequently create tutorial videos. Please subscribe to my YouTube channel. Thank you for watching.